Welcome to the show. I'm your host, Mr. Athide, and in today's episode of Trigonometry in the Unit Circle, we're going to look at trigonometric ratios. You have, in the past, encountered things like sine, cosine, and tangent. We'll see a few more today, the secondary trig ratios, I guess. But we'll also look at how those are connected to points on the unit circle. Now, whenever we have points, we're used to seeing like an XY point of some sort, where this is how far left or right we go, this is how far up or down we go, and that's that. But we can also refer to points using a polar coordinate system. So rather than this rectangular one, where it's just a matter of how far left, right, how far up, down, creating essentially a rectangle towards your point, our polar one relies on theta and the length of a terminal arm. If we have something on the unit circle where this radius is indeed 1, the question is, how can we find x and y to get that particular point? Well, we've got ourselves a right triangle. And based on that right triangle, we can say that the cosine of theta is adjacent over hypotenuse, which gives us x over 1. Well, that means just x is cos theta. Similarly, if we look at sine of theta, that's opposite over hypotenuse, so we get y over 1. And we can say that y is sine theta. Our conclusion is essentially that p theta, the point on the unit circle corresponding with theta, has an x value that is cos theta and a y value that is sine theta. And very critical, this is only on the unit circle. So if you've got some point like 2, 7, and you're wondering, hey, what's theta based on that stuff? No, cos theta is not 2, sine theta is not 7, because that point is not on the unit circle. And there's a whole host of reasons why that can't be in that case. So this is only on the, highlight pink and pink. This is only on the unit circle. Key point. So that's that initial business. We're also going to look at these 3 new trig ratios. There's cosecant, secant, and cotangent. One of those is the easiest one to remember, I suppose, and that's cotangent, such that the cotangent of theta is 1 over tan theta. This is a reciprocal function. You could say that cotangent of theta is tan theta to the negative 1. That is a reciprocal. It is not, give me a color. It is not equal to the inverse function. So this inverse is of a value. Tan theta has a value, so taking the reciprocal of that is a multiplicative thing. Whereas this other case, when we have this negative 1 here, that's the inverse of a function. It undoes what the function does. So just note that. That's cotangent. Cotangent is linked to tangent. For the other two, we've got the following definitions, in that the cosecant of theta is 1 over sine theta. So it's the reciprocal of sine theta. It is not inverse sine of theta. Again, just to be clear. Woo! Woo! And then our final one is secant. And the secant of an angle is 1 over cosine of that angle. If you want to rephrase it, you could say that it's cos theta to the negative 1. And once again, just so we're very clear here, the secant is not the inverse cosine. That's bad. You don't really have to memorize this whole thing. Actually, I think some of them are on your formula sheet. But the key parts are this first line. That is the basis for this definition. The rest, meh. So we're going to put all this stuff together in some examples. We're going to determine the values of the 6 trig ratios given theta is 2 pi over 3. Don't forget those handy-dandy triangles can be useful. This is a pi over 3 family. So if you need to, write down the triangles because they exist. And don't forget about cast rule. So if we're looking at 2 pi over 3, we could say that cos of theta is equal to, well, in this case, cos of 2 pi over 3. In the pi over 3 family, cosine is 1/2. Except that 2 pi over 3 is over here somewhere, which means that cosine is negative. Sine theta, which in this case is sine of 2 pi over 3. Here's your pi over 3. Opposite over hypotenuse is root 3 over 2. Again, this angle is over here, so sine is positive. That one's done. Super pooper. Tan theta in this case is the tangent of 2 pi over 3, which is opposite over adjacent, root 3 over 1. Tangent, again, being over here, tangent is negative. Shabam. There's our 3 primary trig ratios done. And if we want to get the reciprocal ones, blah, we can say that the secant of theta, which in this case is the secant of 2 pi over 3, is the reciprocal of this value. It is not the reciprocal of this. So we're not saying secant of 3 over 2 pi. That's a huge no-no. We're taking 1 over this value here. And by that logic, it is negative 2. Negative 2 is the reciprocal of negative 1/2. That's the connection. So similarly, when we look at the cosecant of theta, which in this case is the cosecant of 2 pi over 3, it's the reciprocal of this thing. Sine of theta is root 3 over 2. Therefore, cosecant of theta is 2 over root 3. And finally, for tan of theta, we're looking at it linked to cotangent of theta, which is cotangent of 2 pi over 3. And this one was negative root 3. You can pretend it's negative root 3 over 1 if you want. And then its reciprocal is negative 1 over root 3. I suppose it's worth pointing out that if you have something like cos theta is adjacent over hypotenuse, then its reciprocal function, secant of theta, would be hypotenuse over adjacent. Because these are reciprocals of each other. And similarly, if sine theta is opposite over hypotenuse, then cosecant of theta would be hypotenuse over opposite. And if tan theta is opposite over adjacent, then cotangent of theta is adjacent over opposite. So we see that reciprocal nature. And if we look at this thing, cosecant of theta, well, it's not going to be opposite over hypotenuse, it's going to be hypotenuse over opposite. And for 2 pi over 3, hypotenuse over opposite is 2 over root 3. Shabam, diddly-am. So note those connections between all that jazz. I'm going to erase it here because it's, if you want to have it in your notes, have it in your notes. I dare you to try the other two. Oh, three on this page. And we'll see some quick ones to solve on the next. It's a flurry of examples. Really, if you want to try them all, go for it. I'm just going to start with this one. Okay, worth noting is that this thing is on the unit circle. If we want to check we can look at x squared plus y squared, which in this case is 5/13 squared plus negative 12/13 squared, which is 25 over 169 and 144 over 169. We get 169 over 169, which is 1. So x squared plus y squared is 1. We're on the unit circle. In that case, we can just straight up say that cos theta is equal to x, which in this case is just 5 over 13. And similarly, we can say that sine theta is equal to y, but y here, what in the hell? Y here is negative 12 over 13. How's about tan theta? Woo! That's exciting. Well, for that, we can use a very special identity, and that's that tan theta is sine theta over cos theta. Or if you want, you can say that based on that diagram earlier, there's theta, and here's our right triangle. We can just say that it's, how you say, opposite over adjacent, right? Which is essentially y over x. So taking that into account, we've got negative 12 over 13 being divided by 5 over 13, which just gives us negative 12 over 5. And if we want the other three, because we got 6 trig ratios, well, then if we want secant, that's the reciprocal of cosine of theta. So now secant is 13 over 5. Cosecant of theta is the reciprocal of sine theta, so negative 13 over 12. And cotangent of theta will be negative 5 over 12. Shaboom. Moving on. This looks like it's related to some real special things. So this one we should recognize as being from one of our special triangles. It's specifically from the 1 root 2 pi over 4 business, because cosine of theta is 1 over root 2. 1 over root 2 is the same thing as root 2 over 2. So we know this is related to one of our special angles. We don't actually have to find what the angle is. We just need the 6 trig ratios. So again, we say that cosine is x, which is root 2 over 2. We say that sine of theta is y, which is negative root 2 over 2. And tan theta is y over x. Which in this case just gives us negative 1. And from those we get our other ones. So secant of theta is 2 over root 2. And if you simplify that, it's just root 2. Cosecant of theta is the flippy-do of that. So negative 2 over root 2, which if you simplify is negative root 2. And cotangent of theta is the reciprocal of negative 1, which is just negative 1. Ta-da! In this particular case, we're not asked to find the 6 trig ratios. We are asked to find theta itself in this initial 0 to 360 degrees range, this 0 to 2 pi. This is what we know. We know that cos theta is equal to negative 1/2. And by the special triangle, we know that that means that we must be dealing with a reference angle of pi over 3. We must be somewhere in the pi over 3 family. This business says that x is negative and y is negative, which means quadrant-wise, we're over here somewhere. So we're in quadrant 3. If we're going to go with quadrant 3, then noting that for this family we're talking about angles like pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. There's your quadrant 3 version. How else can you get that? You could say that in quadrant 3, we have to go pi plus the reference angle. So pi plus pi over 3, which in this case is 4 pi over 3. Ta-da! There are some more examples we're going to tackle, and they are to do with solving some trig equations. And these are more introductory trig equations, so there's not very much to do other than, how you say, apply the trig ratio to it. Some of these you might need a calculator, like this one. So this is a calculator one. Next one is not. This one is. That one's not. Okay. Honestly, I dare you to try them real quick while I try and locate my calculator. JK found it. But how would we solve if cotangent of theta is 4 over 3? Well, my calculator doesn't have cotangent or cosecant or secant buttons on it. I only have sine, cos, and tan. So I'm going to say that tan theta is 3/4. So my reference angle is the inverse tan of 3/4, which means I'm dealing with, so inverse tan of 3/4 is 36.870 degrees. That's rounding to 3 decimal places as per the requirement. If tan is positive, then we are dealing with quadrants 1 and 3. Therefore, theta could be 36.870 degrees in quadrant 1. Or we can add 180 to that and get the quadrant 3 version, which is 216.870 degrees. Next up, if cosecant of theta is negative root 2, what the hell? Well, that's interesting. That's fine. Then we can say that sine of theta is negative 1 over root 2. You can reference the special angles for this if you so desire, or however you know how to get that. I would say that your reference angle is like 45 degrees, but we're dealing with radians. So we're specifically talking about pi over 4. Here's your cast rule. And according to this, sine is negative, so we are in quadrants 3 and 4. So in quadrant 3, we're talking about 5 pi over 4. And in quadrant 4, we're talking about 7 pi over 4. But we could not just go from 0 to 2 pi, we can go as low as negative 2 pi. So we're looking for stuff that's coterminal in this range. So if I subtract 2 pi from this, I also get, so minus 2 pi from that is like subtracting 8 pi over 4. 5 pi over 4 minus 8 pi over 4 is negative 3 pi over 4. And similarly, this one, if we subtract 8 pi over 4, we just get negative pi over 4. So those are all the possible values between negative pi and 2 pi. Since we're doing 2 revolutions from 0 to 2 pi and negative 2 pi to 0, we should have twice as many answers as normal. This next one, secant of theta, is negative 1.287. So cos of theta is 1 over that, whatever that number happens to be. Do I even want to know? 1.287. Interesting. Your reference angle, I'm going to take inverse cosine of, not negative version of this, but the positive version, just so I get the angle that's from 0 to 90 specifically. So my inverse cosine of that value is 39.013 degrees. We are dealing with quadrants 2 and 3, since cosine is negative. Now in quadrant 2, we could say that we're dealing with 180 minus that value, which is 140.987 degrees. And in quadrant 3, we could say we're dealing with 180 plus that, which is 219.013 degrees. But we're not dealing with 0 to 360. We're going from 360 to 720. So we're going to have to add 360 degrees to each of those. And that's how we'll get our answer. So in this case, theta could be, where are we at? 39.013. Oops. 399.013 degrees, or 219. What did I just do? It's something wrong. This is wrong. I need 140.987 plus 360. There we go. 500.987 degrees. And then the other one, 219.013 plus 360, is 579.013 degrees. Whew. I know this is a long one, but last question here. If cotangent is negative 1 over root 3, then tan of theta is negative root 3. And honestly, I don't even remember this. This is root 3, this is 1, opposite over hypotenuse. So we must be dealing with that angle there. Alright, we've got a reference angle of pi over 3. According to the cast rule, we are in quadrants 2 and 4. So in quadrant 2, we're looking at 2 pi over 3. And in quadrant 4, we're looking at 5 pi over 3. But this is only from 0 to 2 pi. And we're going from 0 to 4 pi. Goodness gracious. So we can also add 2 pi to each of those. So for our answers, it's not just, is it working anymore? Great. 2 pi over 3 and 5 pi over 3. Yikes. Yikes. Sorry. So not just 2 pi over 3 and 5 pi over 3, but this plus 2 pi, so plus 6 pi over 3. And this plus 6 pi over 3. And then that one is done. There is some practice work for you at the bottom here. Give it a go. This stuff needs like a ton of practice to really just... Honestly, there's a rote aspect to this, if we're really being honest. Of being able to access some of this information quickly. Which is not the most ideal form of learning things, but really just to give you a sense of what to do in all these various situations. So give those a try. Let me know via Teams or in class if you have any questions or comments or concerns. Anything I can help you with, please just reach out and let me know. That is all I've got for today. So long.